Hey guys, and welcome to Functional Print Friday. And welcome back to my basement shop. Remember this guy from a while ago? I reviewed this on the channel a long time ago. Don't worry, we're not talking about lasers today, but what I do want to talk about is the fume extraction. Longtime subscribers to the channel will remember when I did this whole routing here for the fume extraction on this guy. We actually designed and 3D printed this blast gate. And that was all working really well with one exception. Let me show you where this goes. So that actually exits underneath our porch, and it exits underneath our porch right where our side door is. So every time I used the laser cutter and had the exhaust on, it would smell like a campfire out there by that door for honestly days, unless it was particularly windy out, and that really was not working out too well. And I don't use the laser cutter that often, but there was actually times where I could have laser cut something and chose not to because it was either going to be more than wood fumes or I just did not want to smell it outside. Let me talk through an idea that I have. And before we do that, let me just give you guys an update on some of the things that you're probably going to see in this video, but that are not a subject of this video. And I know if I don't talk about it, people are going to ask me in the comments. I got the enclosure for the Sovol SV08 Max, and so far it is awesome. There's a couple shortcomings, and we're going to address those in a future video, but I am genuinely really happy with this machine so far. In fact, there is a large print in there that I don't want to show you guys yet because I'm not ready to share the details for it. But I have at this point printed, I think, 6 things that almost cover the entire bed that have quite a bit of Z-height to them, and it's done phenomenally. This is the Q2 and the Cheaty box, both from Cheaty, and I've actually had both of these for quite a while now. And the reason you haven't heard about it or seen anything here on at least my channel is because all of the issues I've had with the Cheaty box. And I'm not alone in that. In fact, my tech fund just released a review video for both of these on his channel, and he had just as many issues with the Cheaty box as I have. I've had more failed prints trying to use the Cheaty box than I have had successful prints. The Q2, on the other hand, has actually been very good. It's got a number of design issues that I could nitpick about, starting with the handle. Like, I don't know whose finger they thought was going to get in there. It's actually hard to open because you just can't grab it. Come on, guys. It's a handle. Like, how did someone not test this? Even my pinky finger doesn't really fit in there to grab it. And the magnets hold it shut. Like, it's genuinely not easy to open. The bigger issue is the headroom in the machine. You notice with the glass on up there, I don't even know if it's focusing on that. Let's see if I can force it to focus. Yeah, there's just not enough room between the top of the tool head and the glass. This printer should have been probably, I don't know, maybe at least 50 millimeters, maybe even 100 millimeters taller up at the top. Like, they've actually made the tool head really compact from left to right. Maybe they were hoping to be shorter in Z height and they already had the rest of the electronics and packaging designed. I don't know. But outside of that, this has worked really well. The thing is, I don't really see a market for it without a functioning either multicolor or multi-material solution. So maybe you'll see this machine on the channel more in the future, maybe you won't. I think that really comes down to whether they can work out the issues with the Cheaty box on this machine. And over on this side of my shop down here, you'll notice that my Bambu Lab H2D now has a friend in an H2S. Bambu Lab sent this out to the channel free of charge for us to use in functional printing projects. And I don't know that I'm going to do a review video on this. Honestly, I could probably review it right now in the intro to this week's video. It's excellent. I have yet to find a flaw with it. I'm actually really surprised at the price point that Bambu Lab landed at on this machine. They priced it at, I think, $12.49, which essentially replaces from a price point where they were at with the X1C. And this is so much more machine. I kind of feel bad for anybody that's bought an X1C in the last, call it like 6 months. The build volume on this is 340 by 320 by 340, larger than the H2D because you don't have the multi-material dual nozzle setup that you have in the H2D. A lot of people have complained about the price point on this machine. I disagree. I think this machine right now is absolutely worth the price of admission if you have the need to work with multiple materials. Like, you want to use, like I do a ton of prints, for example, in TPU that I had either couldn't support in the past or had a real issue supporting, and now I can just support them with PLA or PETG. To me, it's worth it for that alone. But for prints that are not multi-material, I don't see a better machine in the price point of this one, especially if you want to work with engineering filaments that require a heated chamber and a high nozzle temperature. I mean, Bambu Lab right now continues, in my opinion at least, to be the leader in both the hardware and software. I'm really excited to see what happens in the next, call it 3/4. Because this machine, of course it does have an AMS and it supports multiple AMS units, no tool changer. Now, I think they've teased that this machine can be upgraded with the tool changer. I believe it's going to fit over here on the side. Whether it's going to be practical to make that upgrade, I don't know. I guess that remains to be seen, but I've gotten some flack in the past down in the comment section for focusing too much on these, sort of next generation machines that, tool changers, or even machines with AMS that, it kind of gets out of the hobbyist price point for people that, are more in that category of spending, $300 or $400 on a printer. But this is the future of 3D printing from my perspective, particularly on the multi-nozzle, multi-material side. This has opened up so many things in the 3D printing manufacturing process that you just simply couldn't do with any manufacturing process only a couple of years ago. So I'm really excited to see what Bambu Lab comes out with for their next generation machines with the tool changer. And also what we see from the competition, because as awesome as Bambu Lab, again, from my perspective, is right now, I'm not interested in a monopoly in 3D printing. I would like to see at least 2 other manufacturers be at the same level consistently as Bambu Lab is. Otherwise, they'll stop being competitive. I mean, we saw that with Prusa. Prusa's slowed down too much on innovating because there just wasn't really any competition. All of their competition was, companies mostly out of China just, one-upping each other on how cheaply they could get a kit or a printer out, at the $200 or $300 price point, or sometimes even less, that offered, nothing above the innovation that we were seeing from Prusa. So Prusa could just take a step back and, not stop innovating, but in my opinion, innovate in the space a lot slower than what the market was ready for. And Bambu Lab came in, kind of ate their lunch. All right, now that you guys are up to date with what's going on down here in my shop, let's get back to figuring this out. Here's my idea. I have a radon mitigation system down here in the basement. There's actually 2 sections where a pipe drops down underneath the slab. There's here, and then over here, I have another pipe that drops down in. And these are all connected together on the other side. So if we follow the pipe up on this side, you can see that that hits a T, and this pipe runs over to that other pipe that drops down underneath the slab, and then the other side of this T goes out to the radon mitigation fan that sucks that up and exhausts it above the roof line. You guys actually saw that in a previous video as well, since we came up with a number of 3D prints outside a grommet up through the soffit, and a rig I designed to increase the size of the hole to swap out the pipe. But when I put that new radon fan in, it was a multi-speed fan. And I think it's set at 5 now, if I recall. And it goes all the way up to 10. I'm thinking, what if we could selectively run the fan at full speed? Would that create enough suction that we would not harm the amount of sub-slab depressurization that we're getting out of these 2 ports, but give us enough increased airflow that tapping into this existing piping, we could use that to not only exhaust from the laser cutter over there, but I would also like to add 2 more drops over here. One to attach to either one of these machines, because if I'm printing, I print a lot of PLA and PETG and TPU. But when the need arises, I do print nylon and other materials, even ASA. You really don't want to be breathing the fumes from that. So I would like to be able to actually exhaust the air from either one of these machines to outside. And over here on my sort of little electronics workstation, I would love to have a drop over here for solder fume exhaust. I don't want to do like a full fume hood, but it would be nice, cut them as an upgrade from this little guy right here, which probably doesn't do much of anything, to actually getting that air, that smoke exiting out of the shop completely. So here's what I'm thinking. Again, assuming that we can up the fan speed, increase the suction, and not impact the performance of my radon mitigation system. That is really important. If you're watching this video and you're even considering doing this yourself, make sure those things are paramount and that you can actually measure them. But let's assume right now that that's going to work out. If I put a T here and a T here, and I have 2 horizontal runs kind of running over my head, this one would drop down behind the H2D and the H2S. This one would drop down, it would hit another T. One would drop down for solder fumes, and the other one would tie into the laser system. They'd all have blast valves, so I could completely isolate them from the system here when it's not running, and then hopefully keep the fan running at the same, much lower speed than what it's capable of for the radon mitigation system, we could just up the fan speed when I want to mitigate, additional fumes from here in the basement shop. So I think that's where we're at now. We have to now figure out if we can make these changes and still maintain the same level of depressurization in this line, and if we can adjust the speed on that fan in some, I don't know about automated way, but something that doesn't involve us going out, taking the cover off the fan and adjusting the fan speed in there manually. All right, I grabbed my multi-tester. Let's go out to the fan control box and see if we can somehow bypass that speed control knob in there to do what we want. All right, so if I recall, there is a knob inside here that lets us set the speed for this fan. Okay, so if we look at the underside of the cover here, we can't tell exactly what's going on. I mean, the motor itself is clearly more than a motor. We'll kind of have to figure that that's a bit of a black box here on our wiring diagram because we're feeding it 120 volts, so hot, neutral, and ground. But then we also have this little guy here, which I'm assuming is probably just a potentiometer. And it's marked negative, positive, and then the center is unmarked. And then it looks like white is unused. And yeah, there's nothing connected with white. I bet you that this guy is just being fed a DC voltage. And the variable output of that is feeding this center. So we can turn this little knob here, try and not block your view, and this will adjust the speed of the fan. So we're at 5. Let's put the tester on here and see what we can learn from this guy. All right, so I've got my meter set to DC, and you see it looks like the terminal that's closest to me here is marked negative, and the furthest one is positive. So if I put probe here and here, and 9.95 volts. So that's probably a 10 volt supply going into this guy. Let's see where we're at in the center terminal. Okay, 4.9. Interestingly enough, we're at 5. I wonder if the numbers actually correspond with the volts from 0 to 10. That would be incredibly convenient. Let's grab my screwdriver here. I'm trying to keep everything in frame so you guys can see it and not electrocute myself here. So we're at 5. Hey, look at that. If we go all the way to 10, does that match the same input voltage? 9.95? 9.95. Okay. Let's go down. Let's go down to like 2. Do we get 2 volts? No. So it's not completely linear. Yeah, that's at 4. And we're getting 4, so I don't know what point it drops off. It doesn't really matter. We don't want to go slower. Yeah, so it looks like it drops off underneath 4, because there's 3, and we're actually at like 2.4 volts. But 5 is pretty much right at 5 volts. A little bit under. So I wonder if this is just as simple as bypassing this guy selectively. Like, what if we put a switch, and when the switch was in the on position, it essentially shorted from the positive terminal to the output terminal of our potentiometer. One, I don't know, somewhat safe way of doing this is probably actually to just use the meter for it. So if we set the meter to DC amps, we switch our leads over. And the reason I'm doing it this way is because by shorting it with the meter in line, if it draws more than 10 amps, our fuse will blow in the meter. But we'll actually see what it's drawing. If this is going to work, it shouldn't draw much current through the meter at all for that short. Probably just a few milliamps for the control signal. So now I'm going to try shorting between what is the output of this little guy and the input. Let's see what happens. There we go. You guys can see. Oh, I'm on the wrong terminal. Just going to touch it first, see if it sparks. No. Oh, and the fan's speeding up. Yeah, so now we're essentially just feeding 10 volts. It's basically the same as setting this to 10. And by the small amount of current we're drawing, I think that's perfectly safe to do. It looks like we're drawing, is that 2 milliamps? Yeah, it's like nothing. And then it returns back to the slower speed. So it might just be that simple. It would just run a separate wire up here. It would be on essentially what is the low voltage side of the circuitry, although I guess from a code perspective, we're still in the same box as high voltage, but maybe we have a separate entrance into here with just a wire that will selectively essentially bridge that plus 10 to our control input. Yeah, I don't know. I guess comment below if you see any issues with that. It sure looks like it works that simply to me. I don't see why bridging between the input and output side of the potentiometer would be harmed there, because that's going to be a higher resistance pathway than the short that we're creating. All right, so let's assume that that's going to work. Let's also set this to 10. Well, no, we need some measurements inside first. Let's go back in the basement. Okay, so I think the next step here, now that we know that we can increase the fan speed with a switch, without having to go in there and turn that knob every time, I think we need to measure the vacuum in this pipe, because we want to make sure that we're maintaining whatever the current vacuum level is. And I actually have what I think is going to be the right tool for that. This is a manometer. I actually got this for free. This was in the trash pile at a company that was getting rid of a bunch of stuff, and I'm pretty sure it works, although I've never actually used it, so I guess we're going to find out. And over on the other pipe, this one actually has one of those little fluid level indicators, and we are like exactly between the 0 and the 1. I don't know if it looks that way through the camera. There might be a little bit of parallax error there, but the top of that fluid line on this side is, from my perspective, is exactly between the 0 and the 1. So we're looking to maintain that on this pipe. So I think we're going to go try and do the same thing on the other pipe, but use the manometer to read it, which should actually be much more accurate than this, in theory, if it works. So I think we're probably going to need to drill a hole in this other pipe. Look at this, it's still got the screen thing on it. I'm not even sure how to use this, so we'll probably be figuring that out in this video too. I'm poking around here in the box. This guy has a CD that's got Windows 2000 and Vista drivers on it, so it's probably a few years old, but my guess is it probably works fine. There's a bunch of stuff in here. I don't think we need this pitot tube. There's 2 hoses. I think all we need to do is connect one of those hoses to what I guess would be the minus side, since we're measuring a vacuum in that pipe, and plug one of these guys in, and then push one of these through a hole that we're going to drill in that pipe. So I don't know. I'm in that dangerous phase of I don't know what I don't know, but isn't that a fun place to be? All right, I've got one end of the tube in the minus here. The other end of the tube we're going to put in the pipe. There's a bunch of different unit options on here. Inches of H2O. I wonder if that's measuring the same way that that other little water gauge is on the other pipe. Let's leave it in that. Okay, so about 0.6. Is that the same as what that other gauge was reading? Yeah, I think we're actually measuring the same thing that we are over here on this drop. That would be about 0.6, maybe slightly more than 0.6. This is also closer to the mitigation fan though, so that would make sense. All right, I slid the filament dryer over a bit so this guy could kind of stand here on the desk. We're still reading 0.6. I'm going to leave you guys in here watching this. I'm going to go out and I'm going to turn that little dial or controller, whatever you want to call it, on the fan up to 10. Let's see what happens. Okay, 1.97, 1.96, that's good news. I think what that means is we have a lot of headroom here. And this closely agrees with the other gauge. The other gauge now is reading about 2.2, which again, it's closer to the mitigation fan, so I would assume there's going to be some difference between these two, but they're still also pretty close. So yeah, I think if we can keep above 0.6, this is probably going to be a success. All right, so I think the next steps here are probably not going to be that exciting to watch. I've got to cut this pipe, add some T's in, run some horizontal sections, and I've got to figure out how to knock through that up there, because I want to have the one kind of coming through this joist bay and actually go through that, penetrate it, so that I can have an elbow that connects to this guy, and then the other one would drop down here. The one that's going to run through the closer joist bay for the back of these printers should be no problem. I just got to figure out, I don't know if I can just leave it hanging down all the time and then just magnetically attach it to whichever one I want to use it on. I got to figure that out yet. All right, guys, it's actually the next day. I have been to Lowe's and Home Depot twice for pipe and fittings, and it is a gigantic mess in here, like literally 360 degrees of just mess all over the place. This is always a really stressful time for me because there's like a lot getting done, but it's just messy everywhere and I can't find anything. I hate it and love it at the same time. Definitely making good progress. Like I've got both of the Ys in here, our little step-up pipes, and the horizontal runs in. This is all just dry fit, nothing's glued in place. Whenever you're working with PVC, I strongly suggest basically get everything connected. Finish all your work before you go back and start gluing in your joints, because it is such a pain to have to cut stuff out and start over again. The further one down here just runs to basically over these two printers and stops there, and there's a cap in it so I can still use the Radon mitigation system. This guy here runs all the way over and through that joist up there, and that joist turned out to be joists. I thought I was drilling through just 1.5 inch piece. Yeah, that ended up actually being 3 pieces up there stacked together. I didn't pull the last cookie out of the hole saw here. I'll tell you, this new Bosch brushless drill, someone actually recommended this in the comments in a previous video. This guy is an absolute champ. It drilled through all of this with no issue. It just took some time because it's overhead, so it's hard to hold the drill, but did a great job. And you can see that sort of just pokes right up through there. It's basically flush with the other face here because a coupling is going to slip over that, and we're going to have one going down along this pole here, and then the other one is going to connect to this guy. We'll bend that back up in there to connect for the laser cutter around the other side. I'm going to pause the work down here in the basement though, because we've got a bunch of parts that we have to actually design. Like, we need a way to adapt from the PVC couplings to the 4-inch flex. We need a blast gate that somehow mounts against this metal pole, because I'd like to operate it from like maybe around here. And that one's going to drop down for fume extraction on this bench. And then this one up here, like, we've got to somehow terminate this pipe or a fitting on the pipe into a blast gate that I can operate, hopefully from standing underneath of it, to pull down to open and close it, and then transition the other side into some 4-inch flex. And that's a fair amount of design work. And even if I can get it done pretty quickly, those parts are still going to take a while to print. So I better go start on that. And when I have something to show you, I'll bring you guys back. So I started by taking a look at the geometry that we already have for the blast gate that we designed about a year ago here on the channel. And in fact, you saw this one printed out in PLA on the wall, sort of above and to the right of the laser cutter. I know this design works well because I've been using it for the last year. It seals really well, it moves freely, I'm very happy with it. There is some constraints with this design, main one being that it's designed to mount up against a flat surface. It's mounted to, I think, like a 1x3 on the wall down there now. And the gate part that slides in, it slides in from this end and then is stopped by the wall. So when you pull it out, there is a retention piece on either side that keeps it from being pulled all the way back out. But when you push it back in, it's basically just stopped by the wall. And that's not going to work because we can't really mount this one the same way. If we were to mount this to the joist like this, I guess that would work. It wouldn't be able to pass through the joist, but I'd be pulling this out horizontally to open this valve, and it's already a little bit out of reach. So ideally, I'd be pulling down on this to open up the gate valve. And we also wouldn't have these tabs sticking way out, because that means I can't mount this down lower on the joist because I've got to give that tab some room. So I kind of moved this around a bit here in CAD and thought, well, how can I redesign this to be a better fit for mounting against the joist? And enter this design. So you can see I kind of thickened the center section, got rid of those tabs, and I have some long, deep holes in here for long screws to go through. And in fact, let me turn on hidden geometry here. We'll just whack this top. Kind of see what's going on better there. So the fastener head's going to pass all the way through this section here, come down to here, and that should leave about just slightly over an inch of threads to go through that joist, which that joist is going to be 1.5 inches thick. So that should work out nicely. And I actually made this large enough so that I can easily pass a Phillips head tool like on my impact driver all the way through this to get that fastener in place. That will not interfere with the actual gate part that we're going to pull out. And then at the back, I added a piece here that essentially acts as a stop. So I also extended the back to make room for that. And then this piece will install after this is printed as a stop. So, we'll print this out, we'll slide in the gate part, and then we'll slide this stop in the back, and then this will be held in place with 4 bolts. And that'll stop us from pushing that gate all the way through. And then this can be mounted against the joist like this. So the joist, imagine the joist running on this side. And I'll be able to then pull straight down on this. I also thought, geez, it might be nice to extend the length of this, because this is what's going to look like all the way in. So that is the gate part of the blast gate here, pushed all the way up against the stop, which I might be able to reach up and grab that, but I thought there's no reason not to make that longer. So I made another adjustment here in just extending that gate. So this gate is also all the way pushed in, like it's up against the stop, but you see how much longer it is. So I should be able to reach up and grab this with my index finger and pull down on this. And in fact, it's probably going to be sticking down pretty far, honestly, when it's open, but that's okay. It's not like I can really walk there, since that the workbench with the printers is there. You'll also notice I modified the diameter of the, well, I'm going to call this the input side, because this will be the side that is the input side, but it doesn't really matter. This is now dimensioned to slip inside of a 4-inch PVC coupler, and it should be a nice snug, more or less like press fit into that coupler, because I'm going to print these in PETG, so we've got a bit higher temperature resistance, since if we're using this for exhaust from the chamber, I can see the temperatures getting high enough, at least potentially, that PLA wouldn't be the best choice here. I think PETG should be enough, but either way, we're not going to be gluing PETG into PVC. At least I can't think of any glues that I would count on to do that. And if we're leaking a little bit of air, it's suction. It's not the end of the world. So as long as this is a nice tight press fit into a 4-inch PVC coupler, I think we're good. And then this side is sized for 4-inch flex, and I'll probably use like a 4-inch clear flex, the same as we used for the dust extraction system that we also did here on the channel a while back. So that solves that, but we also need one of these for over on the pole, where a line is going to drop down that I can use for solder fume extraction. And I scratched my head a bit on that, and I realized that I think we can actually use pretty much the same design. We don't need one side to slip into a PVC coupler, so both sides can be this size, but we just need a way to hold it against the pole. So I came up with this, and I'll turn off hidden geometry because it's kind of distracting now. The long vertical pole, that's not a pipe, that is the pole down in my basement that actually supports that I-beam up at the top. So this will be that steel pole. This is the exact same design as this one back here. So the shorter gate, the same matching size input and output. But I just designed a piece that the screws can go into, as opposed to screwing into the joist. that is basically like a U-clamp that goes around the pole. And here I just whacked the top faces off of here so you can see what is going on. This is exactly the same inside as that other one, so we'll have long screws with the heads that drop down to here. And then the fasteners should come out to right about there. They're not going to come all the way to the bottom of these bores. I realized that we're pulling on this a little bit off center. It would be nice to have this kind of on center over here. And I suppose I could have slid these guys over to better accommodate this one, but I don't think that's going to be an issue. This guy does not need to be snugged up on there that tight. And PETG is pretty tough. I'm going to print everything in this one in PETG as well, including our overgrown U-bolt or strap or whatever it is that we're calling that. Last but not least, and I put this in a different design space, I thought this fit better into my existing design space for all the dust extraction couplers that we did that were magnetic, also a while back on the channel. And this one just simply translates from the inside of a 4-inch PVC coupler or fitting. So for example, we could put this in a Y or an elbow. This side is straight and should slide in the same as the OD of a piece of 4-inch PVC pipe. And again, this should be a nice, snug, almost press fit, or, you know, kind of hard enough to push in that you're not going to be able to pull it back out, I'd say. And then this side is sized for 4-inch flex, whether it be the metal aluminum 4-inch flex or the 4-inch clear tubing flex that we used for the dust extraction. And this is tapered ever so slightly just to make it a little bit easier to put it into the 4-inch flex. So we need a bunch of parts. We need, I think, 3 or 4 of these. We need one of each of these, one of all of the parts for this guy. And that is, each one of these is 1, 2, 3 parts. So we've got a bunch of printing to do. So let me get that started. And in the meantime, I'll start gluing up the PVC that I dry fit everything on. And hopefully by the time I'm done with that and get everything cleaned up down in that basement, these parts will be done and we can keep moving forward on this. All right, with the exception of 2 more parts, everything is done printing. I'm waiting on 1 more of these, and that's a quick print, that won't be long, but I'm also waiting on the second one of these, and that is quite a long print. I'm gonna try and get it into today's video if I can. I think it's probably not gonna finish until about 11 o'clock Eastern, and it is Friday today, so yeah, we might not see the second one of these in today's video. If I can, I will include it. This particular part is about a 12-hour print. But it came out absolutely gorgeous. I mean, the only area that's not perfect is up here because I opted not to try and include any supports inside. So that's a little rough in there, but it doesn't really matter. I mean, the ceiling surface is the outside, and that's really good because I did use supports under here. So this printed down like this, which means we had a support inside of here. And I used PLA as the support interface, and I don't know if you guys can see like how clean that is. I came off in just one piece. You can see I just grabbed into that with some pliers and yanked the whole thing out. But we have a nice clean face inside of there for this piece to fit. That should go in. Yep, drops right in. Of course, I'm not sure how I'm going to get that out, but I'll figure that out. There's a 0.2 millimeter clearance all the way around, so that is, you know, it fits in there, but it is nice and snug. And then this piece was supported on the underside with these guys, and I should have taken them off on camera. I got a little excited when the print was done, and I basically just touched them and they pretty much fell off. It is, to me at least, is an absolute game changer being able to use different material for the support interface. Like it really makes doing complex parts like this absolutely worth the price of admission on a multi-tool head machine. And these just both popped right off. And look how clean those surfaces are. Like that is as clean there as the inside surface here. So hopefully that last part, like this one, finishes, but I believe I have everything else here to get started. So I'm gonna go start gluing things up and pressing things into place, and I'll bring you guys back. Well, guys, I think we did it. Other than the drama of drilling through 3 plates up there instead of the 1 that I thought I was going to have to drill through, everything just kind of fit. That was a little bit easier than I thought it was going to be. I didn't try and roll the camera while I was gluing stuff up. If you've ever glued together large PVC, it's hard enough to do by yourself without trying to have a camera in the way, but everything is now glued up. There's still some more work to do. I mean, this is in, it works really well. I can reach it no problem, but as you can see, it just comes down to an end. So I'm not sure what we're going to do there yet. I made sure I cut it off with plenty of room to get to both of these machines. I don't know if we'll tackle that next week or some other time in the future, but I know there's a bunch of solutions out there already to attach something to the back of one of these H2 series machines, and I don't think I like any of them. I'm thinking more like something that gets permanently attached that doesn't block the vent at all. So if I'm not using this, the vent's not blocked in any way, shape, or form. It can blow air exactly as they intended when they designed it. So maybe something that's just raised, say 10 millimeters around the edge, maybe with some magnets embedded, and then have a piece on the end of this that there would be like a top exit for this maybe, since it's going up, and it has a matching piece that sort of clicks over that, and then that piece would stay attached to this, and I could just sort of pull it off of this and attach it to this one. That's currently what I'm thinking. I'm curious to hear down in the comments if you guys have a better idea, or if maybe there is a design out there that's similar to that one. All the ones I've seen have a piece that gets attached to here, stays on there, and you know, it has a big enough opening when there's not a hose attached, but it really seems like it would restrict the air in comparison to these shutters just being wide open and air freely flowing through there. So yeah, I mean, you know, done but not done, because we still have to figure out how we're actually going to adapt to that hose. Over here, it's a little bit of the same story. I mean, the laser is now completely reattached. It's super hard to see up here. I did not try and shoot installing any of that up there because it's just way too tight, but there is a Y that's attached to the pipe right where it comes through those plates. One end of the Y comes into this that feeds this blast gate on the pole, and the straight on the Y goes into that flex, and that goes over to the laser. So that's completely done. The laser is now reattached. I can use that as is. I can kind of use this too. I didn't put anything on the end. I just sort of dropped it down here. It actually sort of stays on the workbench pretty nice. Like I can use that just like that for solder fume extraction, but I'm kind of thinking it might be neat to have maybe like a little base that's weighted at the bottom maybe like a little knob at the top that you'd grab, sort of like a tripod on it that you could set it down anywhere and it would be raised a little bit, because I'm not always soldering like right down here on the bench. I keep this little guy here on the pole with a clip on the end, and I can kind of position this anywhere I want. And oftentimes I'm soldering something that is in that little, that little arm. So I got to think about that too. But I mean, I can use this as is, and the length is actually perfect to just kind of drop down into this this gap over here between my workbenches when I'm not using it. These are all a little bit tight. I like to make them tight and then let them wear in because they seal really well when they're closed up. I mean, I can certainly move it, but it is a little tighter than I want it. But I know from experience that after operating this guy for a while, it will loosen up a little bit. The pole mount ended up working really well. Again, everything just kind of fit. I was surprised. I got a little nervous as all the parts started to finish and I started assembling because I knew I didn't have time for a V2, but it all fit. And for the control wiring side, I have a Raspberry Pi down here that drives a couple of relays, and I had 2 relays free on my little board here. So relay 2, you notice there's 2 wires in there. Those 2 wires are now running out to the Radon fan and hit those 2 terminals that we tested with earlier in the video. The plus terminal that feeds 10 volts to that potentiometer and the output terminal from the potentiometer. So when this relay closes, it feeds the motor control the full 10 volts, telling it to go full speed. And I have a web API that I can hit this Raspberry Pi right from my phone. So I can turn the fan up to full speed just by clicking a button on my phone or going to a web page on my computer over here and commanding the fan to go full speed. That part ended up being really easy. And I'll put a picture up on your screen here with how I terminated the wire on the control side on the Radon fan. So let's get the manometer hooked back up and see where we're at, because we've now added a whole bunch of piping. All the valves are closed, so we should be seeing, I would think, 0.6 or somewhere close to that. I may not have gotten that screw out there at the Radon fan in the exact right spot. It's pretty touchy. Just a little bit of movement around 5 varies it by about half a volt. So let's get this hooked back up and get a new baseline. All right, so we're reading 0.68 now, so a little bit better than we started with. I don't think we actually improved anything in the existing piping. My guess is I probably just have that screw turned a little bit higher up than we started with. But we know as long as we're above 0.6, we're good. That means that we have maintained the same amount of subslab depressurization that we started with before we modified anything. So, all right, let me now kick the fan into high speed. All right, so it looks like it is settling around 1.8. So let's now go open the blast gate at the laser all the way. All right, so this is basically the worst case scenario. This is probably the only blast gate that I would run wide open, because I think this is probably going to move a lot more air than the previous setup. Oh yeah, it actually kind of sucked the lid down a little bit on the laser. All right, let's go check. All right, look at that. So even with that blast gate wide open on the laser, we're still reading way higher than 0.6. Let's go close that. Now this does reduce down to a smaller size, and this is closed, so my guess is we're probably going to move even more air when we open one of the other blast gates wide open. Oh wow, that's that's moving a lot of air. I know you guys can't really tell because this is just a video. Let me go grab a piece of paper towel. Yeah, that's too much air. And we can't run this one wide open. We'd be sucking way too much air through the printer. So we wouldn't run this one wide open, but let's just leave it. See what the gauge says. Okay, so 0.52. So that does put us under 0.6, but again, I would not run that one wide open. And that's actually still really quite close. So we'll close this one. Just out of curiosity, let's run this one wide open too. Make sure we're not sucking stuff up off the floor. That's interesting. it looks like there is a little bit more restriction through that one. You know, I guess that is a longer run, even though it's a little closer. So, well, that's good. So I know I can run the solder fume extraction one wide open and basically be right at where the system is when the fan's running at the slower speed without that open at all. That's actually moving a lot of air as well. So I probably would not run this one wide open either. Although maybe, I don't know. It is nice to just suck all of the air out of the area where you're soldering so none of that smoke escapes. But I can run this one wide open, so it doesn't matter. Boy, when all the valves are closed and the fan is on high, like you can just hear it trying to suck air from every possible area that it can. It's actually generating quite a bit of vacuum. And you know, now that I think about it, whatever I do here, I should probably make some kind of a grate for this, because like if I had let go of that paper towel, that would have gone all the way through the system and possibly gotten stuck on the impeller on the Radon fan. So I should probably put some kind of a grate on here so that nothing, I don't know, bigger than say like my thumbnail can get sucked through, because anything that size I think is going to pass through no problem. But I could definitely see larger objects getting sucked into there and then getting stuck at the impeller. So a grate would probably be a good idea. All right, so we are back at 1.8. I'm going to go ahead and turn the fan back to the slower speed. And yeah, we're back to where we started. Well, guys, I am really happy with how this turned out. I know we have a little bit of unfinished business as far as how we actually terminate both of these, but I think all of the hard work and all of the messy work is done. I really appreciate you hanging out in the basement shop with me here for this week's video. And special shout out to my patrons. Thank you for supporting all the content here on this channel. And if this is by chance your first time here on the channel, that's all we do. It's all design and engineering and functional printing. So if you're into that side of the hobby, check out some of the other videos on the channel. If you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.